Okay. So we have our next problem, which is this one, and this is problem 3. Okay, I guess I should introduce myself though. I'm an electrical engineering student, and I'm just doing my calculus homework. I'm in my technically first year still. It's the middle of summer, so I'm doing summer school because I wanted to get a little bit ahead before next semester. So I'm taking Calculus 1 over the summer so that next semester I can start off with Calculus 2. Okay, anyways, this one says let g of x equal the integral from 0 to x of f of t in respect to t, where f is the function whose graph is shown. And then it also asks to evaluate g of 0, g of 5, g of 10, g of 15, and g of 30. Here, I'll probably bring that in just as text. Boom. Why is that not? It's not auto changing. There we go. Okay, what am I doing here? Okay, I need to put in this text. And then we'll probably move that just like right there. Okay, well, maybe a little bit more. Just to make it equal. Okay, so G0 is gonna be here. And then you got G5, 10, 15, and then all the way to 30. The way this works is this is like an integral. So like g of 0 is the integral of 0 to 0. And that is going to be, I believe, just 0, right? Yeah, because it's not going anywhere, right? It's just staying right here on this line, so it doesn't gain any area because it's just a line. You can't do that. So I know I'm not going to be writing this the best because the way that you should write it is like integral 0 to 0, and then g, I think you just put 0 in there. But I'm just going to do it in a quicker way so that it makes sense to me. Okay, hold on. Let's take it one step at a time. So the integral to 5 is this one, right? That's here. And then the next one is to 10, which is here. And then 15. And then we have all the way to 30. But there's a few things that I've just seen here. See how this 30 has a weird shape? It's not a triangle or a square, but we can split that up and just make it that way. And then this one as well, I'm going to split that, and then we'll color this one blue. The coloring that I'm doing is not to say like we add all the blues together, add all the reds together, add all the greens together. No, I'm just doing the coloring to help separate the shapes. So let's get all the areas. So I'm just going to say Like, I'm going to get rid of this because 0 is nothing, right? That's the shape there, right? And this equals 5 times 10, so 50. And then we have the integral from, nope, let's do 5 to 10. And this will be both the red square and the top blue triangle. Okay, well, the red square is the exact same, so that'll be 50. And then the blue triangle is the same divided by 2, so that's 25. So that equals 75. And then we'll do the next one. That will be the integral from 10 to 15. And that's our green triangle. And that is 5, 10, 15, 20, actually. If you look at that, the green goes all the way up here. So that equals 20 times 5, because it goes 5 here, over 2. Well, 20 times 5 is 100. Divide that by 2 equals 50. Okay. And then down here, I'm going to color this one blue. And, well, maybe not. Hold on. I'm going to color this one red and this one blue, just to help differentiate. Well, okay, that doesn't, we'll do this one green, just to help differentiate like the different areas that we're adding. And we're only going to 30, right? Yeah. So the integral, and integral is an interesting word. I was saying it to my dad, and he said that back when he was in school, they pronounced it integral. Integral. Yeah, integral. Which I guess you could pronounce it either way, but it was just interesting to me. Because when I see the word, it's spelled like this. It looks like integral to me. It like integral. That's what it looks like to me. But my dad said integral, and that's the only way that you're supposed to pronounce it. So, whatever. It doesn't really matter. We'll do to 30. And this is our red triangle plus our green square. Okay. Well, our red triangle is 5, 10, so 10 by 10 over 2. So that's 50 plus 5 by 10, which is 50. So that equals 100. But the function g is the antiderivative of f. So since this is f, then g prime of, then f equals g prime of x. So we need to find g, which is the antiderivative of f. Which is interesting. But that's fine. So in other words, that means when you take like g of 5, that will equal the 50, right? Just like we found here. But when you take g of 10, you have to add the 5 to the 10 that we found here. So that's 125. And then the next one, g of 15, equals 50 plus the 125, so that's 175. And then we have g of 30, which the integral from 15 to 30 was 100, so we add that and we get 275. And I believe that's correct. I'm just gonna go put it into the computer, like where I answer things. 15 is 175, and then 30 is 275. And then it has a few more questions that I need to ask. It says, on what interval is g increasing? And where does g have a maximum value? So x, like at what x is g a maximum? Well, we can use the given points here to kind of figure that out. Is there a way that I can change this image? Like, no, probably not, huh? Anyways, I'm putting in a new graph. Probably just get a graph off the internet, but whatever. So 5 is 50. Okay, there's quite a lot going on here. So let's do like times these all by 10. So this would be 50, 100, 150, 200, right? Because I think 275 is our highest, which, we'll be fine. We just need to start putting in a few. So 5 is 50, right? That's gonna go here. 10 is 125, so that'll go right in between here. 15 is 175, so that'll go here. And 30 is 275. Well, we have 200, 250, and then 75 would be right in there. So there's our graph. We know that it's positive at the very beginning, starting from 0, and out of the options that we have, only one of them does that. So I'm going to select that, and then we need to figure out where is our maximum on the graph that they give. It goes 5, 10, 15 as the max. Is that right? That's interesting. Oh, hold on. I think maybe we're doing this wrong. Well, maybe not. Or maybe we are. Hold on. Oh, I see what we did wrong. Okay. See how these are below the x-axis? Those need to be negative when we add them all together. Okay, that makes sense. Yeah, I was like, what in the world? I did something wrong. So we're going to get rid of those. Well, I think 15 can stay, right? Because from 30 it just minuses. So it's 175 minus 100. So that's 75. So on our graph below, this one just goes back down here. So curve here. I guess I'll do that in the green. So curve down. And then erase this top. Okay. And that works better. And so x has the maximum at 15. And then it's increasing from 0, 15. Okay, let's submit that, see if we're right. Oh, I forgot to change my answer on G30. 75. Boom, it's all correct. Okay, next question. Why do I keep getting dings? I don't want more dings. I want to be left alone. Okay, this is our next question. I think it's because the mail app's open, so I'm going to close that. Okay, so this is question 4. Also, is anyone watching? I don't think so. Yeah, the live control panel from OBS does not let me log in anymore for some reason. Not sure why, but whatever. Nope, no one's watching. Okay, that's fine. That is fine. Okay, let's see here. Use part 1 of the fundamental theorem of calculus to find the derivative of the function. Well, I guess we can show you here. The part 1 of the fundamental theorem of calculus is that if f of t is continuous on a to b, then the function g of x equals the integral, or the integral, from a to x of f of t in respect to t is continuous and differential, and so g prime of x equals f of x. So that is saying that g prime of x equals f of x. Okay? What am I supposed to do though? Oh man. Hold on a minute, I'm just reading the notes. Okay, so it's saying that like the integral of something is the antiderivative. So this is really simple by just saying that g prime of x is the derivative of the antiderivative function integral 0 to x of the squared root of t plus t cubed. So our answer just gets rid of the integral. So it's t plus t cubed square root. Yeah. Let's try putting that in. Square root t plus t cubed. No, it did not like that. Okay, I'm going to watch the video then. See what they're actually trying to get at.
Calculus to find the derivative of the function.
Oh. I hate it when they do that. Hold on. Let me test something. Yep, okay. I was right, except when they do this, g prime of x, you have to change it to just use an x. And that's our answer. Insert a square there to be like, this is our answer. I think that's a little crazy when they do that, because it's like, obviously this is the answer, but it changes somehow because this has the dt, which is like respect to t, and then when you take the derivative of the antiderivative, they can change whatever variable they're using. And I don't know. I think that's a little crazy, but whatever. Okay, next problem. Make it a little bigger. This is problem 5. Use part 1 of the fundamental theorem of calculus to find the derivative of the function f of x equals the integral, or the integral, from x to 0 of square root of 3 plus secant of 7t in respect to t. And then this is our hint here. It's saying that the same function is equal to the negative integral. How does that make any sense? Okay. Man, why am I suddenly tired? Oh, hold on. I might. Okay. I was just missing something. See that this and this have switched places? Here, we'll draw it like that. That means it becomes negative. But why are we doing that? Also, we're looking for f prime of x. That's what we're looking for. But why do we take the negative? I guess I'm not really understanding why we need to take the negative of the function. I understand that it works, but why? Cause, oh man, by this logic, f prime of x is just going to be negative square root of 3 plus secant of 7t in respect to t. Like, that's our answer. Pretty sure that's our answer. But why? Why are we doing this? Is it because x is first? I think it's something about that because all of our other ones have been x on the top. So that's my reasoning for now. Okay, so negative square root of 3 plus secant of 7x. I'm just going to put x in there because the answer is looking for f prime of x. And it liked it. Okay. Next. I guess I should copy that. Okay, this is our next problem. So, problem 6. I think for the purpose of this live stream, I'm going to go to problem 10. But for my homework, I have 21 problems. So, I won't be done when you guys are done. And by you guys, I mean probably just future me. I don't think anyone else is watching, so that's fine though. Okay. I'm going to draw a little diagram just to help. Let's go 1, 2, 3, 4, 5, 6. But we're only measuring from 4 to 6. So that'd be 1, 2, 3, 4. So this would be x0, x1, x2. Yeah. Yeah, that probably makes more sense. Okay. By the way, I used to use Adobe Acrobat to take all of my notes, just because I thought it was really useful being able to write directly onto PDFs and such. But then I finally switched to this just like yesterday, 2 days ago. I don't know. But I much more prefer this now because I can very easily write and it has like my actual handwriting, the actual pressure. Because, like, see this? I can put down more pressure or less pressure, and it actually takes that into account. And the paper is endless. I can go as big or as small as I want, which is awesome. Because with Adobe Acrobat, if I mess something up and I needed to move something, let's say like I had made all this and I just wanted to move the X's down here, then I'd click on it and it would probably move all of this. Like, it wouldn't let me move individual things, but now I just come in here, take the lasso, and I can move them. Isn't that crazy? It's so much better, so much easier. This is Microsoft OneNote. So, anyways. Okay, I think from here we should probably start just plugging this in, I guess. Let's see. Well, we have 6 minus 4 divided by 2 because there's 2 sections, and that's just going to equal 1, right? So we don't even need to think about that part. So we'll just start plugging things in. 4 squared plus 2 times 4 minus 4. And then we're adding these, not timesing. 5 squared plus 2 times 5 minus 4. Plus 6 squared plus 2 times 6 minus 4. Okay. And so this is 16 plus 8 minus 4 plus 25 plus 10 minus 4 plus 36 plus 12 minus 4. Okay, well, right off the bat, I can see we have 4, 4, 4, that's 12, so that can just take those out. Because 4, 4, 4 is negative 12 plus 12, that's 0. And then everything else is positive from there on, right? So we'll just start combining things. So we have 16 and 8. That's going to be 22. My brain's fried. 24. And then plus 25 plus 10, that's 35. And then 36. Bring that down. These two together are going to be 59 plus 36. And so that will equal 5 on the end, 895. Right? Yeah. 95. From 4 to 6. And let's put that in, see if I'm right. 95. No. Oh man. Okay, what did I do wrong? Interesting. Hold on. Why is that happening? Okay, for some reason, the guy in the explanation video, he's counting it as if this is a 3. Which for me would be 2/3. But why is he counting it like that? I could have sworn at some point they taught us that you start here at x0 and then 1 and then 2 and then there you go, 2. But I'll have to times this by 2/3. I'm just gonna divide it on a calculator, see if it makes any sense. 95 times 2 divided by 3. It's a repeating number. Okay, 95 times 2. It's 190. So 190 over 3. That one didn't take either. What am I doing wrong? Oh, okay, hold on. That's interesting. Okay, I'm gonna write it in green so that we know it's separate. So what they did was they took the antiderivative of that function. So x cubed over 3 plus x squared minus 4x. And then that should have a constant, though, is the problem. and then they did 6 and a 4 here. Or, well, for them it was a 1 and a 3. Because they're not going to show you the actual problem, they're going to show you with a similar problem. And then they put in either of these for the x. So 6 cubed over 3 plus 4 squared. Wait, no. Plus 6 squared minus 4 times 6. And then minus it from that same function but with 4. So like I did up here, this, but using the antiderivative without a constant for some reason. I don't like when they change the rules. They're like, alright, when you take an antiderivative, you have to have a constant that you add. And they're very picky about it. And then they don't do it anymore. Okay, this is 4 cubed over 3 plus 4 squared plus 4 times 4. Okay. Well, I guess I should start doing the math and just simplifying that. So 6 to the third, and then divide that by 3 is 72. 36 minus 24 minus the entire function over here. 4 cubed is 64. I don't think that's divided by 3. No. So that'd be 64 over 3 plus 16 plus 16. So let's combine all of this. That's 72 plus 36 minus 24. That's 84 minus 32 plus 64 over 3. That gets us 160 over 3. And so that equals the 80 minus 160 over 3. 92 over 3. Okay. So I guess my previous answer was close. Not very close though. So let's submit that. Okay, it still did not accept that. Why? Am I not understanding it? Why is that wrong? Do I have to times it by 2/3 then? Is that what's going on? Okay, I'm gonna type in the huge problem. I'm not supposed to add in a 5 at all, am I? 'Cause I did everything he did. Nine plus. Oh! Oh! I'm an idiot. People are probably screaming through the screen. Gosh dang. How dumb can I get? So that's 188. Sheesh. Well, 188 over 3. Okay, that's the answer. I can't believe how bad I am at doing that. I'm always forgetting the sign. Okay, the next question is similar. Just says evaluate the integral. So, this is problem 7. Remember, we're going to 10 in this video, or this live stream, I guess. Dang, I feel stupid. What's wrong with me? Okay, I'm gonna sketch it out. So you got 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. But is he just gonna, or they just gonna want me to do the same thing I did here with just the green? I don't know, that just feels dumb to me. But it is a lot simpler, I guess. Okay, well, that's x to the half power. Antiderivative of that is going to be two-thirds x to the 3 half power. Okay. And then do this and this, put a 9 and a 4. That way we have to do two-thirds times 9 to the 3/2 power minus two-thirds times 4 to the 3/2 power. I'm just gonna put that in the calculator. I don't want to mess with it anymore. Came out as 38/3. Okay, let's try that. 38/3. It liked it. Okay, this is a new way of evaluating integrals. I think it's interesting because doing a summer school is, well, it's just interesting because the teacher, sure, like they've pre-recorded everything and you're learning from those, but you're basically teaching yourself. You get what I'm saying? I'm basically teaching myself for all of these. And so with the questions that I have, I'm just learning as I go. Okay. I'm not going to sketch it out this time. I'm just going to go straight into it. Well, I'm going to write this in a way that it makes sense in my head. Because it kind of makes sense to say, like, t to the half power. That's the t squared here. And then just bring this up. Hmm. I'm just thinking about it. They don't even have a video connected to this one. I'm just not sure if I'm doing it right. You know? Oh, man. Well, okay, it makes sense that it'd be +1, right? Because if you were to take the derivative, then it'd bring this down and leave 1. But then you also have to worry about like inside and outside functions. Okay. How to take the antiderivative of a product. Why are there so many ads? Hmm. Okay. From what I can find, okay. I'm just gonna erase this. From what I can find, you separate the two parts. So you have U, and, well, maybe I should put it over here. U and some other variable. I'm gonna say Y, no, V? Sure. So U equals 13 minus T, right? And V equals square root of T. And then for U, you need to find U prime. That'd be -1. Maybe that's wrong though. And then in a way, it's saying that this is already like V prime. So in order to find V, then it'd be um 2/3 T time to the 3/2 power. And then integrate or into, yeah. It says next, apply the integration by parts formula. What is the parts formula? Okay. So the parts formula is integral u dv equals uv minus integral v du. Okay. Okay. Well, by this logic, then we'll have integral, probably should put the 0 to 4 there, u, which is 13 minus t, and then dv, which is square root of t, equals u times v, which is 13 minus t times 2/3 t to the 3/2 minus integral of v and v is times du, which is -1. Okay. And then it says simplify. Hold on, I'm thinking really hard right now. Okay, that's what's going on, I think. Jeez. Okay. Well, in a way we can keep the 2/3 out, and then we have 13 t to the 3/2 minus t to the 1/2 right? Is that right? I think so. We have 4 here, 0 here, and then because this is a negative and that's a negative, that becomes a positive, right? And then the 2/3 should come out, right? Because constant or whatever does not stay inside of an integral or integral. I'm trying to say it right, or the way other people say it. I'm so used to saying integral, but I guess that's not accurate. Whatever. Okay, and then we can do what we did here. I'm going to switch to green to do that. So we'll have wait a second. Oh, I did something wrong. This t here should not be a half, because it's adding instead of minusing like I had in my head. So it's adding 2/2, so that's 5/2. Guess this one doesn't really matter, but it's okay. Let's try and simplify this a little. So 4 to the 3/2 power is 8. I want to know how I can do that in my head though. So let's do 4 cubed equals 4 times 4 is 16 times 4 is 64, and then square root of that equals 8. Okay, cool. So I'm going to bring down the 2/3, and then 8 minus, and we'll do 4 to the 5th equals 1024. And then square root of that is 32. So that's 8 minus 32 minus 2/3 times 0, right? Yeah, those shouldn't change. Okay, that's starting to get simpler. What's 8 minus 32? The 2, 6, so 30 minus 6 is 24. 24 divided by 3 is 8, right? So you just have 8 times 2, and that's 16, because that'll be minus 0. Okay, so 16 is the first half, but do we add in the last little bit? That's my question right now. Did I not? Hold on. Wait a second. Wait. Oh, okay. I'm supposed to times 13 to this 8. So that's 104. Um, 104 minus 32 is 72. Can that be divided by 3? It can. Then times it by 2. So 48. Okay. Okay. So we do need to add in that other part. So we'll have plus 2/3 times the integral here, and that one should be simple. So the antiderivative of that is going to be, so we'll have a t in the middle, and then we need to add 1 to the 3 halves, so that'll be 5/2, and then we times it by the reciprocal, so 2/5. Okay, and then I think we need to do the same thing we did here, right? I think I'm just going to divide out the 2/3 and keep it on the outside for this one. So we'll have 4 first. So 2/5 times 4 to the 5 halves minus, and then the other one's 0. So 48 plus 2/3 times, oh, excuse me, sorry. Two 5 times 32. So I guess we could times these together. So it's 48 plus 4/15 times 32. Okay, I'm just going to put that in my calculator, make it easy for me. So that equals 848/15. Okay. I have hesitations. 848 over 15. Well, it accepted it. All right. Next problem. We have 2 more problems until we're done with the live stream. And this live stream has been going for an hour and 20 minutes already. Oh boy. Okay, next question is this. And it's problem 9. Wait, that's not it. That's not the right one. That's the right one. Okay. So we have... okay. Well, the derivative of this is the same, so the antiderivative won't change. So we know that one. But this one... looks like we just do 7x to the e plus 1 over e plus 1. And then we're adding here. Oh, my chair's getting uncomfy. Okay. And then we evaluate it. So, if we plug 1 into everything, then that is going to be 7 to the e plus 1 over e plus 1 plus 5e to the 1. And then, well, minus, if we plug 0 into everything, then that's 0. Wait. Yeah. 0 plus 5. I wonder if it would accept that as the answer. Just this long thing. I'm gonna try it. It did not accept that. I kind of thought it wouldn't. Okay, I'm gonna watch their video then. Well, hold on. Their answer's just like mine. Oh, no, it's not. No, it's not. Because if you plug 1 into it, then that's 1 to the whatever power, so it's just 7. Okay, that's what I did wrong. Well, let's try that. Okay, that's right. So 7 over e plus 1 plus 5e minus 5 is the answer. Okay. Last question. It just says a graphing calculator is recommended. Sketch the region enclosed by the given curves. And you have y equals square root of x, y equals 0, and x equals 4. And then calculate its area. Okay, I'm pretty sure this is the graph, so I'm just gonna bring this one over. And then write 10 for problem 10. And then we need to find the area of it. The graph is y equals square root of x. And then what we also need to know is that x equals 4 and y equals 0. And that's just to say like where it stops. So it stops here, stops here. Okay. How do we get the area then? Why don't I remember? Maybe I need to go to yesterday's stuff. We can estimate it pretty easily. But getting the actual area. Huh. Why can I? Okay, well, we know area is the integral, and this is going to be from 0 to 4, and it's of square root of x in respect to t or whatever. Maybe it's respect to x. I don't know. So I guess we could find like the antiderivative. That's gonna be, no, that's wrong. 2/3 x to the 3/2. And then, right, what we did before. Just plug 4 and 0 in. So 0 is going to be 0, so we just plug 4 in and we get our answer. So, whoa, that's a weird 2. 2/3 times 4 to 3/2 power. 4 to the 3/2, I believe we did that up here. 4 to the 3/2 is 8. So this is equal to 2/3 of times 8, which is 16/3. Is that it? I'm gonna try it. 16/3. It's right. Brilliant. Let's do one more. Oh, maybe. Never mind, I need a break. The next one's really hard. Let me at least show you guys what it is. There it is. This is our next problem. It's problem 11. But I'm gonna take a break. My throat's getting dry, so I probably won't stream anymore after this, but whatever.